Hola amigos, so now let's start dynamic stability, and before that we will just recall a little bit of static stability. That the static stability of an object is just the tendency of the object to come back to its equilibrium position or equilibrium state in a finite time. So remember, it is just a tendency. The object may not even return to its equilibrium state, but it should have the tendency to come back to its equilibrium state, and that is what we define as the static stability. And for the dynamic stability, we must know that the object should not only have the tendency, but it must return to its equilibrium state in a finite time. For an example, like the doors we have in our homes, mostly they have, when you open the door, they come back to its closing position or closing state where they rest because of the recoiling that is at the back of the door. So the door not only has the tendency, but it comes back to its closing position, that is the equilibrium state, because of the recoiling of the door. So that is what is defined as the dynamic stability. So and another example is a pendulum. So we know that a pendulum, when disturbed, it will oscillate about its mean position. So to make it come back to its mean position, there must be a resistance force. So air acts as a resistance force, and that diminishes the oscillations over a period of time, and the pendulum come back to its equilibrium state, that is at its mean position, over a period of time and stays there. And that is what the dynamic stability of the pendulum is. Okay, so it not only has the tendency to come back to its mean position, but also it actually returns back to its mean position. And similarly, we can see over here that the airplane which we are seeing over here was flying initially at an angle alpha e over here. In the bold diagram of airplane, we can see the airplane was flying at angle alpha e from the free stream velocity v infinity. So from v infinity, we can say direction of v infinity tells us that the airplane was flying horizontally in the straight horizontal direction, whereas it was pointing nose upwards at an angle alpha e. So it was initially, it can be taken as the equilibrium state of the airplane over here. So for the time being, this bold airplane is actually an equilibrium state of the airplane, which is flying at an angle alpha e from the v infinity. And let's say there's a high wind that is blowing around the airplane, and it pushes the airplane upwards so that the airplane nose points upwards, and the airplane comes to the dashed position as shown above the solid diagram, and it attains an angle alpha, that is the bigger angle alpha from the v infinity. So for a dynamically stable system, the airplane must come back to alpha e, not zero angle but alpha e angle, to its equilibrium state, initial state, which was alpha e. So it must come back to its alpha e state by its design configuration, and it should come back and stay there over a period of time, and that is what is defined as dynamically stable airplane.